I am Charles Isbell. I am a professor in the School of Interactive Computing and the Dean of the College of Computing at Georgia Tech. I love AI, and I've always loved AI. I love machine learning, and I've always loved machine learning. And the reason for this is really simple. When I was very young, about 8 years old, and I decided that I wanted to do computer science, even though I wasn't quite sure what it was. What had excited me about it was the notion that I might be able to one day build something that was as interesting and smart as all the people around me. And as I learned that that was AI, and eventually decided that that meant learning, and therefore meant machine learning, I just decided that I would dedicate my life to it. So the notion of human-centric AI as being important is, it's fundamentally important. It's not just an important thing that one might want to do to make a slightly better product or to do slightly better science. It's the whole thing. To me, asking the question of whether human-centric AI is important is like asking the question of whether human beings should be involved in the design of anything that involves human beings. Because of the promise of AI, the promise of machine learning and these big, cool devices we're building, whether they're in the world and embodied, or whether they're virtual and part of the computer systems that live around us, no matter what that is, fundamentally the goal is to somehow impact human behavior, somehow impact what's going on with humans, and hopefully making their lives better or at least simpler. And so you can't possibly do that well without having human beings involved fundamentally in that process. You would not build a car without thinking about what human beings look like, what makes them comfortable. You would not build tools without thinking about what human beings are capable of doing with them. And at the end of the day, what is AI going to be but a shared, intelligent, and interesting, but tool that's going to work with human beings? So it is fundamentally crucial. It is so crucial, it shouldn't even be something that people would consider controversial. I think the biggest barrier for the adoption of AI is by end users, by normal people out in the world, is simply calling it AI. And I'll tell you why I think that is. When people say AI, they have this kind of notion in their head of the Terminator or some kind of intelligent, HAL telling you, I'm sorry, you can't do that, Dave, or whatever. And they're not thinking about it as simply intelligence and automation and something that is augmenting what you're doing or simply being smart about what you are. So one answer to that question is, well, it's an absurd question, because in fact, people have been adopting AI for years and years and even decades. They just haven't been calling it that. So I actually think that what we really need to do to get more energy put into AI qua AI and to get more acceptance of it by the world is simply to help people to understand what AI actually is and what it isn't. It is not the end result of AI, that is an intelligent, autonomous thing that lives out in the world and does whatever it is the current most popular movie says it does. It is in fact anything that is intelligent and adaptive and works well, at least in my view, with others. So I actually don't think it's really a question of a barrier. It's really a question of understanding what it is we're getting out of the technology as we develop true full-fledged intelligence, and simply accepting it as a part of our everyday lives, in terms of as consumers or otherwise. Right. So when you think, it's actually very important, I think, in this notion of what does it mean to build and deploy AI that's going to be useful and productive and helpful, to think specifically in terms of human spaces, right? So what does it mean to be in a human space? Well, it means that there's at least one human there. In practice, there's multiple humans there. And really, I think there's a very simple kind of test. If I were going to build something that's intelligent, then what would I want in a world where another human being was following me around everywhere and was somehow interacting with me, right? That's kind of the sort of basic test in some sense. So as you build these things and you want to deploy them out of the human spaces, you have to think fundamentally, there's another human being. If I were interacting with that person, what would I want? What would I want to protect about that person? What is it that that person must have in order to maintain dignity and autonomy? So if I'm going to deploy some piece of AI technology out in this room or out in my bedroom or following me in a car, I have to be a sort of confidant and someone who will always follow Chatham House rules, right? That the things that I see and the things that I do with you are between us. I'm like a lawyer or a priest or a psychologist. And I have to think about you as an autonomous person who has things that are special to them and that I'm not supposed to share them. And I think that's not a small thing. I think it's it feels right if you weren't asking about deploying technology, but you were asking about bringing another human being along, another intelligent creature or agent along. You wouldn't even think about these things. But what's the difference really? I don't think there is one. We have to think about and maintain agency, autonomy, and privacy of the ultimate end users. Now, there's some interesting edge cases there about, well, what if someone is doing something self-harm? What if someone is doing something that is illegal? But we have those same rules now for when human beings are engaged in that. Lawyers have limits to what confidentiality is, as do doctors, as do psychologists, as do psychiatrists, as does everyone who interacts with people. But I don't see that the rules are fundamentally different. So when you're trying to figure out where you bring human beings into the process of designing AI for them, I mean, the answer is, there's a flip answer, which is at the very beginning, before you think about anything else, even before you think about exactly what it is you're trying to accomplish, you need to have human beings in there. But that's a bit too cute by half, because it's more complicated than that, right? You actually have to understand what it is people need, not just what they think they want. You have to understand how the implications of giving them what they ask for will help them or will hurt them. People are almost always happy to trade convenience for all kinds of other things, including quality of life, but they can also not understand the implications of the technology that they're asking for and what it might mean. Maybe they don't care about it, maybe they shouldn't, but maybe they should at least understand enough to know what it is that they're signing up for, as it were. So when you ask a question like, well, are there other examples out there of where people have thought through how to bring people in? For me, the answer is, it's hard. It's hard for me to think about specific industries that have been very, very good at this, even though you would think I would know that because I interact with a lot of these, and I think about this a lot. I think what typically happens is we think about a specific end goal. There's a particular product, a thing that I want to produce in the end, and we sort of go down that role, and then we bring people in. And we say, well, how do you like this? And maybe we adjust here and there, so on and so forth. And it's quite different from what it is we're actually trying to do here when we want to build true AI. And when I'm answering this question, I'm thinking about this problem in a sort of big sense of a partner, someone who's going to be with me and everywhere. What does that actually look like? How do you get human beings kind of involved in that? And I think you have to get them in at the beginning, and you have to kind of develop what's going on. I'm going to say something that I only believe about 75%, but I think at least gets us in the right direction. This is less like creating a specific product that exists in the world, a particular device. This is more like building a story with someone. I want to create an experience, an ongoing experience that'll be useful for the end user, which means that the kind of industries that have thought about this are the ones who build stories, the ones who build video games, the ones who test movies, the people who try to understand how a particular political policy idea will fly with the public, people who actually bring them in and try to understand what's motivating them. It's not necessarily for the same kinds of reasons. They're not really building a product to help people necessarily. They're trying to understand how people will react to what they're doing. But I actually think that's closer to the kind of process that you would want to have when you're fundamentally trying to build a person for someone, a partner for someone. So that's actually where I would get my inspiration from if I were trying to think about how to do this. How am I going to build a story that people will like, and how will I get them along in the process so that they get the things that they actually accomplish, and I can elicit from them what it is they're trying to do. When you think hard about this as a notion of experience, there's an interesting trade-off between giving people what they react to and they want, and helping people to come up with something new that they want that they didn't know that they actually wanted. And there is a trade-off between making someone happy or feel as if they're happy and making someone better. As an educator, I feel like I'm in that bind all the time, right? I can certainly make my students happier in the short term, but that doesn't necessarily make them better. It doesn't make them more educated. It doesn't make them more capable of being productive in the long run. And so there's this really, to me, and I don't have a good answer for this, but there's really, to me, a kind of fundamental question about when I'm building something, am I building it for the next 5 minutes, for the next 5 days, or am I building it for the next 5, 10, and 15 years? If you think truly about intelligence, that you're building something that in principle, you would give someone when they were 2 weeks old and it would grow with them. I mean, as a kind of artificial intelligent thing you might build for someone. There's some interesting ethical questions there, but there's also just a kind of fundamental question of what does it mean to build something that will live long enough and will be general purpose enough that what it must be must change significantly over its lifetime, right? It's different from building a light or even building a car, which you don't expect to survive but so long. You're building something that may have much bigger impact, and it really is a question of not just the experience, but the experience for a very long time. And I think that that's not something that we spend a lot of time thinking about. And so I think it's kind of promising and interesting that we might have to start thinking of a horizon over decades as opposed to a horizon over months or years. People ask me all the time, what do you do exactly? And I tell them, I do computing. And then they say, okay, particular kind of computing. And I say machine learning. And then they go, ooh, because machine learning is a thing right now. But, that's a conversation I have when I don't think someone really wants to know what it is that I do all day. When someone really wants to know what it is that I do and what I think about, I try to explain it like this. I am interested in understanding AI and AI that adapts and learns over time. So I do machine learning. When you look at where I publish machine learning papers. I've been doing it for 2.5 decades now, all things told, more than that actually. But I'm interested, even though I'm a machine learning researcher, I'm interested in the AI problem. I'm interested in the problem of building something that we would recognize as intelligent. Now, for me, in order for something to truly be intelligent in a way that is meaningful, it has to be intelligent with people, not intelligent like people. So we are all, interesting little creatures, not because we exist as in a vacuum and we can just think on ourselves. We're actually interesting creatures because we interact with others. It's actually how a lot of our learning happens, right? We learn by interacting with others. We get transfer of knowledge, generation to generation. And I think that is sort of where the sweet spot is around AI. So what I do is I focus specifically on problems of interactive AI. That is, where you're trying to build agents you would consider intelligent, where those agents must be able to live with other agents, not just one or two, not just dozens, but hundreds, thousands, perhaps tens of thousands, some of whom might be human. And what that means is you cannot say, well, I'm just dealing with other intelligent beings and therefore they're all on machines. And so I can just send XML packets to them back and forth. I'm going to have to figure out language. I'm going to have to figure out how to infer intent. I'm going to have to figure out people who are long-lived and therefore will change what it is they're trying to accomplish. So it's not a task that I'm trying to solve. It's not simply a goal that I'm trying to achieve, because the specific task that I need to solve will change over time. The specific goal that I want will have to change over time, including because I'm interacting with other beings with goals that sometimes work with me and sometimes are at odds with what I want. So I have to adapt as time goes on. And so you really want to focus on that interactivity and that ability to learn from and learn with others. So at a high level, that means that I spend time on things like game theory. How do you interact with other intelligent beings where you can guess or maybe even know what it is they're trying to accomplish, and do it in such a way that you aren't creating a zero-sum game and a conflict. I worry about things like programming languages and how you would even express something that is going to have to exist beyond a task. I worry about things like goal inference. I don't spend as much time on that as I wish, but I worry about things like goal inference and how you're going to figure out what other people want and then act accordingly. And so, one could dive into a lot of detail here, and there's a lot of math, and I could tell you some equations, and I might even remember what most of those equations mean. But in the end, it's really about trying to build something that will exist with something else that is intelligent, some other agent, and we'll be able to adapt to more than one task at a time, and we'll be able to kind of move on. I'll give you a very simple example of this that I'm currently working on with a colleague of mine and a student I think is quite interesting because it's so simple. You're in a car and you're about to get onto the highway, and there are all these other cars on the highway, and some of them are trying to get off the highway. So as you're entering, they're trying to exit. You know that the people you're interacting with are intelligent. You know that they have goals. You may be able to guess what their goals are. But somehow, without communicating directly with them, you don't go brain to brain, you have to figure out how to act. And you don't know whether this particular person is a crazy person who likes to drive fast or is going to slow down to let you in. You don't know exactly what's going on. And yet somehow you manage this every day, at least if you drive, all the time. And you've been doing it for years. And even young people who first learn how to drive figure out how to do this pretty quickly. And that example of just kind of merging onto traffic, merging into a highway or merging often or whatever is a kind of microcosm of all kinds of things that we do that are not just task oriented, but they're also fundamentally social. They're about understanding what is considered the right thing to do in a particular situation, understanding by the small things, the small actions that someone else takes, what it is they're perceiving as what the goal is, and then reacting accordingly to it. And that brings it to the amount of effort it takes to kind of understand what to do in that situation is extremely difficult, but very different from the sort that you would do if you were focusing on how to win at Jeopardy or how to play a game of Go or chess. But it is in some sense the kind of thing that as intelligent beings we do all the time, often without reflection. But it is incredibly difficult for a smart AI to do. Oh, by the way, think about this for a minute. You're driving down a car. You're driving down a highway. You're just driving down a road with one lane this way, one lane that way. At any point, the person on the other side of the road could just decide to kill you, and you couldn't stop them. It's insane. Why do you ever get in a car and drive down a road? You're surrounded by missiles, effectively, all of which could destroy you. And if the person across the road decides, you know what, I'm just going to run into this person, you're dead. There's nothing you can do. And then you're going to do it at 60, 70, 80, 100 miles an hour. It's absolutely insane. And yet we do it all the time because we make all kinds of assumptions about what other people are doing and why they're doing it. And we have limitations that we put on ourselves through social pressure and as well as a host of other things about the way we're going to behave. And by the way, if you're in the United States, you do this by driving on the right side of the road. And if you're in some other parts of the world, you do it by driving on the left side of the road. You do it by, if you're in Atlanta and someone tries to get in front of you, you have to let them go because that's the right thing to do. But if you're in New Jersey and someone is trying to get in front of you, that's a challenge for territory, and you're supposed to cut them off. And the rules are very different depending upon whether you're in Boston or California or in Atlanta, or even what parts of those cities you are. And yet somehow we move around and we adapt to them relatively quickly, even though we've all come to completely different localized answers. It's an incredibly difficult problem, and yet we manage it somehow. And it is in some sense a fundamental test of intelligence, is how you're going to navigate both physically and socially with other intelligent beings. So this is a basic question, right? How do you build in all the common sense, as people like to say, particularly in a world where while they talk about common sense, also likes to say common sense isn't all that common, right? How do you build this? And then if you can do this, if people do this, how do you program this into machine? So there's kind of two questions there. One is, do I believe it can be done? And the answer is, well, I have to believe it can be done, otherwise I wouldn't be doing any of this. So yes, but how do I think it can possibly be done? What actually gives me hope that this would happen? And the answer is that for me is, I can't tell you, oh, well, if you just take your favorite programming language and you add these 5 data structures, it's all going to work out. But I do think that there are some kind of fundamental approaches that one should be thinking about and that give me hope that this is possible. The answer is yes, we can build this. And in fact, we must build these kinds of notions in. And I think the way we do it is around story. We tell ourselves stories about how something is supposed to happen. And we build up these kind of data structures and experiences that allow us to generalize from one to the other. What does it have to do with built-in assumptions? Well, there's a whole bunch of assumptions built into that. The assumption is that other people are like you, and that they are doing the things like you are, and that you can predict what they're going to do because you know what they're going to do. There's some evidence that shows that when you think about what someone else is saying, you're basically sub-vocalizing it. So you're interpreting what someone is saying or doing or how their mouth is moving or whatever, in some sense, by thinking about how that would project onto you and what's the most likely thing to happen as a result of that. And so you're kind of fundamentally building this idea that the things I'm interacting with are like me, and they have the same desires and drives and the same physical limitations and so on. Now, this is a problem if you actually don't have anything in common. physically or psychologically or whatever, because you may not even have a fundamental language upon which you can agree about what's happening, because common sense no longer works because you don't even see the world the same way. But I think that if insofar as we model our intelligent agents so that they can be thought of like us, or they can think of themselves, as it were, like us, we'll be just fine, because at the end of the day, we will have the same underlying language, which means we'll have the same underlying assumptions about the way the world works and why people would make or why other agents would make the kind of decisions they make, or the sort of moves that they make, like physically as they move throughout the world. So I think it's possible, and I think it's really about building in a kind of, I don't know if this is the right word, but I'm going to use it, a kind of physics about how other objects that are built like me must be moving through the world and must be thinking about the things that they do. It's a large game of projection, really. Sure. So when you say something like humans aren't just in the loop, they are the loop, what you're really saying is they're the central point of the exercise, that you have to take into account who they are, what they need, what their needs are, how they sort of move and interact in the world. And by the way, every time I say move and interact in the world, I mean both physically and socially. I mean all kinds of things about that. It's kind of a multidimensional, not just a 3 or 4 dimensional space that involves emotions and predictions about behavior and all kinds of things happening at once. And so if you're going to build something that is intelligent, that is supposed to work with humans, then you have to understand what humans are, and the humans have to understand what it is that you are. And they're going to make assumptions about that. As people, it's what we do. We don't really have a choice in that. Otherwise, we couldn't behave. There's just too much information going on. There's too many things that could happen. Any minute now, all the air molecules could move to one side and blow out this wall over here. I just have to assume that that's not going to happen. I have to assume that when I'm driving down the road, that the truck on the other side isn't going to swerve and hit me. I have to do that, or I'm paralyzed. And in fact, I'm not just paralyzed, I can't even be paralyzed, because not moving, I have just as good a chance of being hit by something as moving around. So you have to take all of that into account, and you have to build agents that are going to do that. But I don't want to overstate that. Right? A part of what it means for humans to be in the loop, for humans to be the center of what's happening, is that human beings are doing the same thing to everything else around them. Humans are saying, I need to adjust myself so that I can interact with this intelligent thing that is in front of me that might be human or might not be human. There's a reason why we anthropomorphize everything. It's because it is an easier way to think and to treat about it. There's a lot of evidence out there that people do this and that they're going to react accordingly. We name little kids name their robots if you have them build it, right? We name our cars and our boats and various other things like that, right? We think of Siri as a person who irritates us, or Alexa as someone who's doing what we're asking her to do. In fact, the fact that we decide that Alexa or Siri is a he or a she is not an accident. It's a way that allows us to kind of think this through. So we will also adapt to those. If you've ever watch someone, or even do it yourself, but it helps if you watch from afar. Watch an adult talk to a child. You very quickly see that adult changes their speed of the way they talk, the words they use, they repeat certain things in a different way. They negotiate with the child what level that child is at. And the child is negotiating back, and they both adjust to a level that they're comfortable with so that they can communicate with one another. And that's exactly what you're, in some sense, being asked to do fundamentally here. You want to build an intelligent bank that will communicate with, by negotiation, of what level everyone is on, and people will act accordingly. In my own work, I have seen this quite a bit, where people will, actually there's a really, I think a nice little story here. I used to work on a system called Cobot. Cobot was a little bot that lived in this text-based world, where there was no purpose to the world other than kind of social interaction with people. There were thousands of people from all over the world who sort of interacted. And we discovered something you might call the assisted Turing test. So everyone knows what the Turing test is, right? Can I build a machine that would fool a human being into thinking it was human by the way that it talked? We never intended to do that. It was too difficult to do. We had lots of cool things that this particular agent could do. But one of the things that we discovered is that when you put Cobot in the same world as a human being, Cobot could talk, and could say interesting things, but didn't quite have it all together, couldn't quite hold a thread. And so what people would do is they would interact with Cobot by simply changing the way that they spoke. So instead of saying something like, how are you doing? I'm fine. What are you doing tomorrow? I'm going to go out and play. Well, that sounds great. They would instead say things like, how are you doing? Oh, I see that you're fine. What are you doing tonight? Oh, you're going to go out and play. They would keep the bot on task by talking to it and bringing enough context that would keep it in the conversation. And they did this without being told how the system worked, how the natural language worked. They did this without any kind of idea from the designers of the system of what its limitations were. They all of them, hundreds of different people who interacted with Cobot, adapted almost identically on their own based on what they were getting back from the bot. And if you asked them about it, they weren't even aware that they were doing it. And yet they were, because this is what we do. So the question of ethics is crucial and key. And the reason it's crucial and key is, well, there's a couple of reasons. One is computing. It's not just AI. This is just computing, period. Computing, computer science, is everywhere, and it's increasingly everywhere. And increasingly, we have access to each other's data, including data you don't even think about. I mean, this watch knows where I'm going. Google already knows what I'm going to be doing next. I'm 100% sure of this. I have a Tesla, so Elon knows what I'm doing and where I am and so forth. And there's so much data from which you can infer so much about people. So there's just kind of a fundamental question of knowing everything about everyone. And that brings all kinds of issues of ethics and privacy. And in particular, if you really think, like I do, that interactive AI, that AI only in the service of other human beings, only working, or other intelligent agents and working with other intelligent agents is sort of the whole point, then you're forced to think about the implications of what you do and how it impacts these other agents. Never mind the more sort of long-term ethical questions about what does it mean to create an intelligent thing that might be seen as only being in service of another intelligent agent. But I actually don't like the framework or the formulation of it as ethics. I like to think of it more as responsibility from which ethics might flow. That what's really happening here is you want to create an idea of you are responsible for the consequences of the intelligence that you birth, or the systems that you build, or the algorithms that you design. And it's about being responsible, which means taking into account what the consequences are actually going to be. So from a point of view as a researcher, that becomes a very kind of personal question, but I actually think that the real place where it makes a difference is at the educational level, where you teach people what it is they're supposed to be doing and what it is they're supposed to be thinking about. You don't teach them as we normally do. Oh, here's how you program, here's how you think about objects, here's what AI is, here's what machine learning is, here's some data science, whatever, and then have them take an ethics course at the end of their 4 years as undergrads. Georgia Tech has had a requirement for ethics going back well before I got here, so more than 2 decades now. We've always been doing this kind of thing, for example. But the truth is, it's the very first course I taught, but the truth is, it's a single class. It's mostly done in isolation, and the students take it at the end when they're already thinking about their next job and it's already moved on. That's the wrong way to do it, and of course, we're trying to adjust to this. The right way to do it is the very first thing you ever do. When you write your very first for loop, when you write your very first piece of code that does anything of any significance whatsoever, you start thinking about responsibility. You see how even this very simple thing that you're doing can have wide-ranging impacts on someone, whether it's gathering their data or crashing their machine or whatever. It is these simple little building blocks from which you can build anything you want to. It means you must infuse responsibility and thought about the consequences and impact of what you do right then and there. If you aren't bringing it up before the first time you do a group project, before the first time you build a piece of code that's more than 100 lines long, it's already too late. You've already treated it as something you staple on at the end, not something that you think about from the beginning. Someone said this to me, or a version of this to me once, about security. And I think it applies to security. I think it applies to AI and machine learning, data science, and I think it applies to computing. The mistake that people make is they think about tool sets to begin with. What's a tool what's the hammer that I have that I can do something? As you get better and as you think more about it and you develop more, you start thinking about skill sets. What are things I can put together that allow me to make decisions and to move forward and come up with insights? But that's not really what's going on here. What you really need to worry about is mindsets. Mindsets are a way of thinking. They're a fundamental way in which you think about what it is you are doing and how it's going to be taken and consumed by the rest of the world. Things like ethics, responsibility, privacy, all of these things, these are mindsets. It has to be the case that before you write that first line of code, before you even sit through what the requirements are, you've already got it in your head that it is simply impossible and unthinkable not to worry about what implication this is going to have on human beings, whatever the end product is going to be. If you aren't thinking about privacy and data, if you aren't thinking about what happens when this machine tells me to do something that I'm not going to do, then you're building a bridge without worrying about whether it falls. And how is that possibly acceptable? Just because it's hidden behind lots of code and teams of people working on things and further hidden behind this and further hidden, and there's all these layers, doesn't mean it isn't fundamentally important. So when I'm asked a question about ethics and responsibility, I think the answer is it has to start at the very beginning, from the very beginning of your education, or otherwise it's just a thing that you add on at the end. And that responsibility, if I can, be a bit too much on the nose, begins with the education and with the educators. It's something that we have to believe. It's something that we have to pound into people's head from the beginning. Just like we were teaching lawyers, we spend the whole first year getting them to think about how law works before they actually go off and do law. You have to spend your time thinking about the impact of what you're going to be building long before you ever get the tools necessary to build it. It is not only important that we teach the people who are building the systems to think about the impact of what they're building. It is at least as important, perhaps more important, that we teach people who are not going to build those systems but are going to be impacted by those systems to think about what those implications are. And that has to start as early as possible. There's this kind of notion of computational thinking. Jeanette Wing first coined that particular term. Lots of people have used other versions of it, but it goes to this notion of mindset, this idea of this thinking in a particular way. The scientist thinks about how you do discovery and how you create falsifiable hypotheses, right? The engineer thinks about fundamental trade-offs, whether they're speed or whether they're cost or whatever. They just think sort of fundamentally about that. And the computationalist does something very similar. The computationalist understands, if I can be just a bit parochial for a moment, that models, languages, and machines are all equivalent. And that power is crucial in thinking about abstractions. It's also crucial in understanding that even though I'm living in this abstract world over here of models, that model is a representation of something that's going to happen in the world. And that model is itself executable, and so therefore will impact the world, or at least could impact the world. And that idea, while being a kind of, theoretical way of seeing computing, quark computing, is also, I think, the beginnings of a way of understanding how that way of thinking, that what you do actually does impact and touch the world itself. So you have to find a way to take something like that, which is very high level, quite nuanced and subtle, and drive it down to something that an 8-year-old can actually get and understand. And that's not that hard to do, because at that age, you already know what a secret is. You already know what lying is. You already know that there are things that everyone doesn't know, right? When children are very young, they think their parents know everything they know, right? At some point, about the time they learn to lie is when they realize that other people do not know everything that they know. Right? So they have already a notion of privacy, whether you call it that or not. And so being able to, if a 3-year-old can figure this out or a 5-year-old can figure this out, then certainly we can help people to think about the devices that they have and that they're listening and that these have these implications and what does that mean for them. So for me, the question of that idea of teaching ethics, responsibility, the implications of what you're doing, even all the way down in K through 12, is important, not just because, or even primarily because, it's going to give us a nice bedrock from which our future engineers, our future computationalists, our future scientists will build really cool things we'll all enjoy, but because it gives a basic foundation that will allow people to be good citizens who understand what's happening, so that when we do these human-centered designs, the people we're working with, as opposed to working on, will be able to understand the language, at least fundamentally, about how these things will impact them, and will be able to be full participants in the design of what they want, because they understand what the consequences are, and they can begin to see what the trade-offs are. So that requires citizenship, in some sense, requires education, and it requires education about the implications of all these great little computational devices as early as possible, in a way where people don't even think about it as being difficult. They just think about it as being fundamental, in the same way they think about privacy as being fundamental. When we talk about human-centered design, right, when we talk about bringing people into the conversation, we have to be very careful, right? Because we don't just mean bringing in someone, we mean bringing in multiple people, because we're not just designing something for a specific person or even a specific kind of person. We're designing it for broad swaths of people. And by the way, if we decide that's too hard, I'm just going to design it for this person or this kind of person, whatever I mean by that, then you're actually limiting not only what the capabilities of the system are, but you're also limiting kind of access to this support from a broad set of people. So fundamentally, this means that you have to bring in people, as many people as you can, from as wide a background as possible to be a part of your team, both the team doing the development, this is important, and also the team that's going to be a part of your design, who's going to be the receiving end of what you are. Because otherwise you end up in ridiculous situations that are embarrassing and bad, but you also end up in situations that are long-term bad for society as well as bad for the individuals in them. So for me, one way of thinking about that is in terms of diversity. I certainly have strong feelings about that. But we can step back from my own personal feelings and just ask the question, what happens if you don't do this? Well, what happens is you build an entire society where people think heart attacks are a thing that happens in the way that they tend to happen to males. And so when women have heart attacks and their symptoms tend to be different for good biological reasons, they're much less likely to know and much more likely to die as a result. Right? We know that breast cancer behaves differently in men and in women. Most men, if you just grab them off the street, don't even think about themselves as being susceptible to something like breast cancer, but it turns out men are. But we think of it as something that involves women and women only. That is bad. And when we take that to AI, we talk about systems that are going to make predictions about people, then it's even worse. I'm going to give you a very simple example of something. This was, became somewhat visible out in the world. There is a system, a very well, nicely put together system that would take images, sort of low quality images, and generate realistic pictures from them. And it's very nice. And you could show this. And there's, it got some acclaim, at least in the research community, from some very good people who do some very good work. Then someone noticed that if you take Barack Obama and you pixelize his image, it will generate white guy, which seemed a little strange. And people started doing that with different people. And it turned out that, at least for the purpose of this discussion, this was a system that very much wanted to turn everyone into white people, which, you either decide you care about or you don't. But regardless, that seems like an odd thing, particularly if you're going to use the technology in the system to do various kinds of predictions. It means you're all but guaranteed that you're going to have surveillance systems that work well on some groups of people and merge other people together, making it more likely that they will be in trouble or not, right? Or that they will be identified as something they're not supposed to be out. There's a picture of me floating out there where it turns me into someone who looks, I like to say absolutely nothing like me, but does look somewhat like me, but oddly and very identifiably, at least if you're from the United States, as white. And that seems a little strange. But there's a deeper question there besides, well, what's the math there and why did that, The question isn't why did it work out that way in the sense of the math, in the sense of the algorithms. The question is, why didn't it occur to anybody building the system to test for these cases? Like, how did you not? Because it's embarrassing for everybody. Well, it's because I suspect that there wasn't a team of people testing it, thinking about those kinds of issues. Because why would they? It's much easier if you're male sitting in a room of 8 males to not notice that there aren't any females in the room, right? But maybe if there were females in the room, things would behave differently. It's much easier if you think everybody in the world is between 5'2" and 5'8" to design for people between 5'2" and 5'8", not worry about people over 6 feet tall. Pick whatever thing you want to pick. But if you don't have diversity among the people who are doing the designing, the people who are doing the testing, the people who are involved in the process, then you're all but guaranteed to have an overly narrow solution, which will, as these tools get more and more powerful, become more and more dangerous for more and more people and hurt more and more people because they are focused over here when the other problem is perhaps different and even more acute, over here? So to me, it is a fundamental question that you have to have diversity of experience, diversity of thought, in a whole bunch of ways and a whole bunch of dimensions, or otherwise you're all but guaranteed to produce something that will ultimately not simply be a failure, but actually do active harm. So there's a really simple reality about how you share resources. It's that the people with the resources tend to resist sharing them with people without, because it's very easy to slip into a zero-sum game. But I think the truth here, very easy, and by the way, very easy for me, very easy for anyone. I'm hardly immune from this. I might be slightly more aware than some others because I feel like I've been perhaps on the short end of that stick before, but that doesn't mean I'm not blind to it when I'm the one who benefits from the status quo. So the first thing to recognize is that, when we benefit from the status quo, we tend to find reasons to like the status quo. That's fundamentally step zero. I think step one, though, is to realize that in the end, because it's not actually a zero-sum game, we will all benefit if we get more and more people involved, that the pie will grow, and that we have to look beyond whatever it is that we currently sort of see around us. That means that people in leadership, whether they're presidents of universities or deans or they're CEOs and CTOs, whether they have the resources to do it or they know the people who have the resources to do it, whether they're scientists and the gatekeepers, it's actually quite important. The gatekeepers, whether they're professors or they're high school teachers, have to recognize that biases exist and that they need to bring in as many people as possible. In exactly the same, in fact, it follows that if you buy the idea that human beings have to be a part of the design process, that they aren't just a part of the loop, that they are the loop, that you need to bring them in, then it also follows that you have to bring as many people as possible into that discussion. Because if you didn't have to do that, then the very premise itself is broken. So once you buy this, it kind of follows that you have to bring as many people as possible. And so the people with the resources, the people who can affect change, have to simply be willing to do that. And I think the good news is most people in these positions, when the opportunity is put in front of them, and it's not necessarily a path of least resistance, but it is a path of not too much resistance, are willing to do it. So then in order to make that effective, you have to actually be honest with yourself about the data and ask yourself, what is it? Where's the place where you can have the most leverage? Where's the place where I can put just a little bit of energy in and get the most output? And that answer is different from every place, but it is driven by data. It is a real thing that is an empirical question that we can figure out. If I'll give you a very simple example in the professoriate level. There's a long story here, but the short version is, if you look at where faculty come from, it turns out that if you just look in terms of rankings, 50% of all faculty in the top 55 ranked departments come from just 10 places. Now, you can argue about whether that's good or bad. I have my own opinions about it, but it is what it is. Basically, there's just a small number of departments, in computer science, there's a small number of departments that basically seed everyone else. I claim that they have a responsibility to make certain that they are bringing in people who have a broad range of backgrounds and seeding that out there so that others who are not going to be at those 10 places can be exposed to the right set of people. They can create the right set of gatekeepers who are going to be there and have a broader experience, and so on and so forth. That doesn't mean that number 11 through 55 are not important. They are important. But if you have to be focused on how you're going to make a huge, big, and immediate difference, then you have to make certain that the people who in this case have the power and the influence are willing to accept that, I use the word again, responsibility, and to act accordingly. By the way, when I tell you that the top 10 departments produce 50% of the faculty, if you look at underrepresented groups, like for example, Black faculty, it turns out that they themselves actually basically produce all the Black faculty that they themselves consume, right? So they're not immune to this, and they do have an enormous amount of power in the way that they spread knowledge and the way that they have influence on the world. So I think that in the end, everyone has to be involved in the game. You have to accept it as a natural consequence of what you believe about the centrality of sort of humanity in this very question that we have, and accept the responsibility that you need to accept and how you can affect that change, and then act accordingly. I mean, I hate to be that simple about it, but it's really that simple.